Hello, everybody. We're going to talk about 2.4 notes. We're going to talk more about phase change and what's happening in between phase changes. So you'll want to pull out your notes template that should be in your packets, and we're going to turn to notes 2.4. So the first thing you need to remember is your solids, liquids, and gases. And yes, we do have the plasmas, but we're just going to kind of ignore those for now. So in my solids, you need to remember those molecules are very, very tightly compacted. They have a definite shape, meaning no matter where I throw it, it's going to be the same shape. So if I take my desk, for instance, if I try to throw it in the garbage can, it's not going to change the shape. Same thing with the volume. The volume of that desk does not change no matter where I put it. Those molecules are very tightly compacted, and remember, they are vibrating very, very slowly. When we then move to my liquids, they're a little bit further apart. These liquids take the shape of the container. So if I pour some water from my coffee cup onto the floor, that water will take the shape of the floor. However, volume-wise, it will be still the same amount of volume. Then we take a look at my gases. My gases take the shape of whatever container they are. These are the ones that don't like to be near each other, so they spread out and try to get away from each other. So they will fill whatever container they are in. These guys are very, very far apart, and they move very randomly. So my three states of matter, again, are my solid, liquids, and gases. So if remember, in a lot of these are terms that you are familiar with. So when you go from a solid to a liquid, that's referred to as melting. When you go from a liquid to a solid, that is freezing. When we go liquid to a gas, that is either usually we refer to it as boiling, but you will also have evaporation or vaporization. Then if you go the opposite way, a gas to a liquid, we have condensation. Now you'll notice down here that I actually have a solid to a gas and gas to a liquid. These are things that they completely miss the liquid phase. So when something goes from a solid to a gas, it is referred to as sublimation. The best example for this one is dry ice. This is what they use to keep things very, very cool when they're shipping. And so when it melts, quote unquote melts, it's not a big mess like an ice cube would be. So that's referred to as sublimation. So when we talk about energy and phase changes, we remember there is always energy being added or taken away. We look at things being endothermic or exothermic. And the way that we determine this is we look at what the heat or the energy is doing. Is the energy going into the system or is it going out of the system? So endothermic is when energy enters. It goes into the object from the surroundings, whereas exothermic is when energy is exiting the system. So you've seen this before. This is our phase change diagram, okay? The way that we label this is, notice how my temperature is always on my y-axis and my heat energy is on the x-axis. You'll notice when we move left to right, we are adding energy. And you'll notice we are always adding energy as we move left to right. However, you'll notice that I have a few plateaus here where even though I'm adding energy, the temperature is not changing. So let's work through every step of this. So in A, we have a solid. We have those molecules increasing in temperature. And remember, temperature is measurement of average kinetic energy. So if we were to compare here to here, the only difference is those molecules are moving a little bit faster, but they are solids. They are very, very tightly compacted. But then when it hits this point right here, this is what we refer to as the melting point. This is when those molecules now start to melt. Well, what is the difference between a solid and a liquid? The difference is those molecules are a little bit further apart from each other. So when we are on this plateau right here, all those molecules are doing is they're moving further apart from each other. You're still putting energy into it, but instead of that energy going to making them faster, those molecules are actually increasing in the space that they have between each other. And then once all of them are melted, now that energy goes into making them go faster, because now you'll see my temperature is rising until again it reaches the point of what we refer to as the boiling point. That is when that energy that you put into it, it's not getting any faster anymore. How do we know that? The temperature is not changing. That energy is now going into making the arrangement of those molecules increase. We need more space between the liquid molecules and the gas molecules. So during a phase change, during this plateau, we are changing the arrangement of those molecules. We are not making them go faster or slower, and we know that because there is no temperature change, and temperature change is my kinetic energy. So if we look at this right here, this is another one. Where would be my freezing temperature be on this graph? My freezing temperature would be that first plateau, because if I were to label these, this first slant would be my solid, my second slant would be my liquid, my third slant would be my gases. During my phase changes, these are my plateaus. I have two. I have one here and one here. So my freezing temperature would be -5 degrees. My boiling temperature would be 5 degrees. We are going to go over a lot more of these graphs in class just to make sure that you understand what is happening at each of those segments in the graph.